Hello and welcome to the School of Computer Science and Information Technology here at University College Cork. My name is Utz Rödig and I'm a professor in computer science and I'm also the head of school. And what I'm going to do in the next minutes is I'm going to explain to you the different undergraduate degree programs that we have, and I do that in the hope that it helps you in choosing the right program. And before I do that and go into the details, I will talk a little bit about what kind of people usually study computer science. I will try to explain a little bit what computer science actually is. And I will also discuss job opportunities that you will have at the end of studying computer science. Okay, let's have a look at computer science at UCC. So let's start with looking at who studies usually computer science. Well, you study computing if you like problem solving. Underneath every computer system that is built, there is first a problem that has to be addressed and solved. So you would normally naturally be interested in this and like problem solving. You need to be creative because once you have a solution, you have to put that into an application, into a system that has to be designed, and that is the creative process. You usually also enjoy teamwork because, contrary to some beliefs, computer science is not kind of an isolated endeavor. You normally put systems together as a team, and so teamwork is an important aspect. You usually want to make an impact because with computer science you can reach quite a lot of people. So think about designing a computer program which is used by millions of people. So you can make a difference to quite a lot of people. You need to be keen to learn because computer science is a fast-moving field and there are always new developments and you need to keep up with this. So you would need to be having an interest in wanting to learning new things. It allows you as well to seek broad opportunities. So computer systems, as you will see later in my talk, are used in many different business areas. And so it kind of gives you the opportunity to really go into very different directions. So let's see what computer science is not and what it is. So what is not computer science? Well, you might enjoy playing video games or maybe even making a PowerPoint presentation like this one, browsing the web, using Facebook, WhatsApp, Netflix, and so on. So these kind of things, that is using computers, that is not computer science. So what computer science is looking at the workings underneath of all these applications. So it's the study of computation, of information, software, systems, and so on. And computer science has many different specialization areas. So for example, some people look more at the data these systems create, or you focus on the human-computer interaction. So somehow these systems need to be designed that people can actually use them. Or computer networks, for example, how our internet functions and works and how this is constructed. Or computer security, which is my area of research. So computer science is about broadly making computers, making applications, but it's as well to make computers useful for the people that use them. So it's a broad area looking at more than the applications itself, yeah, how these are made and how they can be put into a useful context. So let's see kind of where computers are used and what we do with them. Well, first of all, there is to say that 99.9% of computers nowadays, they are not kind of your classical PC that sits on a desk that I'm using here to record this message, right? Most systems are kind of small embedded computers that you find in many areas of life, right? So for example, if you have a smart home, then you will find devices in there, and of course these are computer systems. If you have a smart city, they are in there. Of course your mobile phone, which is a bit more traditional, but as well in factories that automate production processes and so on. These are all computers that are used and kind of make these systems function, or large engines and so on, or cars. Right? All of these things, they have at their core computer systems, network computer systems. And of course all these industries, all these areas, they need computer science graduates that make this actually work and happen, right? no industry that's out there can deliver nowadays their products without computer science graduates. So there's a high demand, and it's quite diverse, as you can see from that. So there are many different areas. It's not just a PC. There are interesting problems out there, and there's a lot of interaction as well with other disciplines. Yeah? So it's not just computer science. There are other disciplines like engineering, psychology, and so on that you need to interact with. So let's look at an example where computer science is necessary. So I used here this picture of a smart city, right? So you might have smart street lighting, the cars, your bins that might be monitored. So a lot of things in smart cities, they get automated to improve our lives, right? And in such an area, you need kind of graduates with different skills, right? So for example, if you have all these sensors throughout an entire city and they collect data, what do you do with this data? Someone needs to analyze it, understand the statistics, understand what we can learn from that, right? So that's kind of one aspect. Or for example, you have people that have to live in such a smart city and it needs somehow to work and support the people. So there's the question of human-computer interaction, human behavior and how it relates to these systems. Of course, there's the question of how do we build all these different systems that you see there, like cameras, sensors, backend devices, servers, and so on, the networks in between. And so what you need is an understanding of software engineering, networking, and all these kind of things. Right? So all this requires computer scientists. And this is also then the reason for this broad variety of companies that will employ computer science graduates, right? So you would have some companies that you expect to be hiring computer scientists like IBM or Google, right? Because it's very close to computer science. But of course, there's many more. There are kind of banks, revenue is listed here, governments, airlines, and so on. All these different industries have computer science at their core as well, and need therefore computer science graduates. The employability of UCC computer science graduates is excellent. The vast majority is at the end of their studies employed or continues on further studies. There's a strong increase in demand for computer science graduates. So industry is really looking for computer scientists, and as a result, the starting salaries are quite competitive. And as well, after a few years of experience, salaries are then growing quite significantly. Computer science at UCC offers 4 different undergraduate degree programs. So there are 2 BSc programs and 2 BA programs. And what I'm going to do now is in the next minutes to explain a little bit the difference between these programs and how you might want to go about choosing which one is the right one for you. So the BSc in computer science is about theory and practice of computer science, while the BSc in data science and analytics looks at using data to make informed decisions. The BA in psychology and computing looks at the understanding of human-computer interaction, so how people interact with machines. And the BA in digital humanities and information technology looks at cultural and societal applications of computing. And so just from this, it might be a little difficult to see which one to choose. And so what we do have is a bit of a flowchart, which hopefully helps you a little bit to choose what kind of option is the right one for you. And so we start with one question to try to see which category might be more fitting. So are you interested in technology and its applications? Right? So that would be the initial question to see if you want to see if any of the computer science degrees is the right one. And so then you would look into, well, do you like puzzles? And would you say that you're logically minded? Would you think that mathematics is kind of something that interests you? And If that is the case, then you fall probably here in my slide on the left-hand side, which are the BSc degree programs. And if you would more think that you would like to work with people, to use computers to solve their problems, then this you would probably fall more in your interests on the right-hand side in the BA programs. And so within both of these categories, there are then two further elements to choose from. So if you look at the BSc in computer science, well, that would be for people that are keen to understand the scientific and engineering principles of computers, like the deep inner workings of machines. And also, if you would have an interest in very advanced topics like AI or cybersecurity or, let's say, embedded systems. So in this case, the BSc in computer science is probably the right thing for you. If you are very much mathematically minded, then you would probably look at the BSc in data science and analytics, where you would look at combining statistics with computation for decision making. So that would if you answer these questions with that would be me, then you would fall in the BSc area. And if you're interested in psychology of how people use computing devices and how technology can be made more human-centric, so how can we actually make systems such that people really are able to use them and can use them efficiently. In this case, the BA in psychology and computing would be the right thing. And if you're interested in humanities in general, and how computing skills can be applied for cultural and societal benefits in general. In this case, probably the BA in digital humanities and information technology would be the right thing. So why would you choose UCC? Well, UCC ranks quite high in the World University rankings, and as well within Ireland, computer science is ranked 3rd. Our staff has a very international profile, and it is important, I believe, to have an international perspective on the subject when studying. And most important, we are a research active school, and staff, by carrying out research, stays up to date with most recent developments. And this is very beneficial when we actually teach our subjects. Last element is that we have a world-class environment for teaching. So we have state-of-the-art teaching labs and specialist equipment. So for example, for embedded systems. And the teaching environment is as well important when teaching. So regardless of which program you choose exactly of the 4 undergraduate programs that I detailed, there are some common elements in all of the programs, and the most important thing here is that we do not make an assumption of prior computing experience. So we do not assume that people that come in on our programs can already program and maybe much more. If you would know already computer science, you would not need to study it, right? All of our programs will have programming elements and, of course, problem-solving elements. There is a hands-on, industry-relevant part to it. So we aim to teach elements that are relevant to industry, which also shows in our employment for our graduates, right? So they can go to industry because we teach what is relevant there. As I mentioned before, we have state-of-the-art teaching labs and equipment, which of course all the degree programs benefit from. There is an emphasis on teamwork and collaboration throughout our programs. So none of these are designed to do everything by yourself. So there is teamwork and interaction. We also have work placement programs. So there will be an opportunity to be placed in industry and gain some experience while you're studying. Of course, the qualifications are internationally accepted. Right? point. So this is in common to all of these degree schemes. Finally, I would like to look a little bit more in detail the content of the 4 different courses. The first one is the BSc in Computer Science, and here we look at the theory and practice of computing. So this is about understanding how computers work, how to become a proficient computer programmer, how to build complex software systems, and topics here include networking, databases, web or cybersecurity, and advanced topics such as AI, mobile apps, gaming, and the Internet of Things. Then the BSc of Data Science and Analytics. So here in this program we look at data and data-driven decision making, how you make predictions based on data using machine learning, and as well how to analyze and in particular visualize big data. So if you have vast amounts of data, how you can actually show and deal with this information. The BA in Psychology and Computing, so that looks at understanding computers and the users and their interactions. So how do computer interfaces and behavior affect users? How best to design systems for disparate users? New ways of interacting with technology using sensors, for example, as well as speech or gesture. And the BA in Digital Humanities and Information Technology. So here it's about combining computers, culture, and society. So it's about digital competencies, communication, collaboration, digital content creation, online privacy. It's about web applications and text analytics for the humanities. So I hope that this gave you a good overview on our undergrad degree programs and how to maybe choose the right one. And more information is on these programs as well, more detail on our webpage, which you find under www.cs.ucc.ie, and of course as well on Facebook and Twitter. So thank you very much for listening at this recording.